Number 13 is pretty simple. We're just going to finish this tiny script of computing a polynomial. So the input that we have is a, which is a vector, x is a scalar, and in our script we have p, which stands for the powers that we have in this polynomial. And we just want to find the output y, which is the answer, which is this basically p of x. We want to evaluate this. So p of x has to equal a scalar. So we want to make sure that once we do all the multiplication within this script, that we add it up all. So let's start off by saying sum, right? We want to sum up everything. And then whatever is going to happen inside of here, that's what we're going to do. So we have a, we're going to assume it's a row vector. So a is a row vector, and it has all the values of a. So it's a1 through a5. Then we have x, which is x times 1's 5, 1. So that's equal to just this. And then p is also a row vector. So that's just 0, 1, 2, 3, and 4, right? So we want to raise each x value to each power of p, and then we want to multiply it by each value a. So what we could do is just change x into a row vector, right? And that will make life a lot easier. So if we do x prime, that will just make it x, 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 x. And then we can do some array multiplication. So if we say x prime and then dot to the power of p, that will equal this row vector, which is x to the p1 essentially, x to the p2, x to the p3, and then so on and so forth until x to the p5. Then we want to multiply this thing by each value a. So if we do a dot multiply, this whole thing will then equal basically this row vector. We have a x to the p1, or that'll be a1 x to the p1, a2 x to the p2, dot dot dot, and so on and so forth, right? That will work because we use dot multiply, so it's going to be an array multiplication. So a1 will be multiplied by x to the 1, and before we even do that, we're going to have x to the 1 to the power of p1, right? So if we just write a dot multiply, and then in parentheses, we want to do this first, we say x dot to the power of our vector p, and we have to make this prime because this is a column vector. We want it to make a row just like everything else. And then we can just close this. So once we get our row vector right here, which is a dot multiply by x prime dot to the power of each value of p, if we sum it all up, that will give us a scalar value y. And that's how you do number 13, which is poly 5.